Hello everybody, welcome to my new project. I intend to make a new signal generator, and I will analog, not digital. I have a digital signal generator. The only point is I have to have another feature to this. A sort of a dip meter on this side, representing this meter here, and what the actual intention is, the signal generator will function as normal. The only thing what I'm going to do with the analog is that I'm going to create a list, as you can see on the left hand side here. This is the list of the frequency counter I made, the frequency meter I made, so all the frequencies are on there. So the range of this signal generator is quite bigger than our frequency meter, but that doesn't really matter. It's only at the higher band or the lower band you don't get that. He goes lower and higher, so this doesn't really matter. Anyway, what I wanted to say is this signal generator will function as normal, so I make it sort of a device here which you can buy. I had to come up with some solution that I have an arrow that I can see what I'm doing. So that's what I meant. Actually it's just a needle, you know, from sewing needle, what I put in here with a washer, a plastic washer. So I drilled a little hole in that washer completely through into the metal, and I pinned the needle in there, so you have a nice needle there to read with. Okay. Anyway, that works perfectly, and so I made the front of the signal generator. I'll put everything aside for a moment. So put that up here. All the knobs that are necessary to do this. Put the meter back. You can see here on the layout, if you can see properly. Yeah. You have our dialing for the frequencies. Then we have our switch for that, so you can and then we have our switch here for the dip meter, and our tuning knob. So you can tune that meter that it dips. Then you have a switch here, generator off or dip off. You switch the generator off, then the dip function keeps functioning, so the dipper will go back to its normal position. And as soon as the oscillator, what you want to measure, is getting in that frequency, then you can see that also. But I'm going to try to explain now how it should work, how it will work. That will work. Anyway, now, so as imagine you have a receiver you want to realign or align on, say, on the emitter bands, and you know you have an IF frequency that's taken from 455 kilohertz. Just for argument's sake, take the 80 meter band, so that's 3.5 until 3.8. That will be 39.55 lowest frequency, and 42.55 high frequency. So what you have to do then is to get your signal generator onto what I said, 39.55. Yeah. Then use your same band switch and tune the meter till it dips. Yeah. When you achieve that, you don't touch this anymore. You switch the generator off. Take your lead here onto the oscillator, and if your oscillator is at that frequency, that meter will dip. So that also make sure that you have the right frequency. So well, some of you will know that all the harmonics of that frequency are present on that oscillator, and it can be sometimes extremely difficult to pick the right point of that oscillator. The point is, if you say put them on 3955, you think you put them on 3955, then you tune the band up to that 4255, then you discover that the oscillator is not there. The signal won't come through. So that's obviously you have the wrong position of that oscillator. So all the harmonics counting there. So some of you who have done this procedure, they know when you know what you're doing, it is easy. When you don't know what you're doing, it's most difficult. So anyway, so just to prevent that when it is difficult to get them on the good frequency, you can use the dip function to do that. So that's what I dreamed up in a couple of days. So you all can see the valves are involved. There's an EF95 twice, an ECC 83 and an ECC 81. So I have a part, a schematic. I use that on the other signal generator. You can see it here. So you have here the oscillator. Then you have here your tone, your modulation, and here you have your I can't get the name. Dear. I'll get to it in a minute. So anyway, you can tune your signal down, and you have another attenuator on there to get it even more down. So this frequency counter is here. That will be our dip meter. So the schematic is not present on this sheet. So we have that somewhere in a book. So I have to keep to my own drawings and what is in the book. So anyway, that's the intention what I'm going to do. The other thing is I'm going to do it on camera. I'm going to build that frequency of signal generator on camera, so you can follow through. So if you want to join me in that, you're welcome. But do to think about it. All the things you do is for your own risk. So you can't blame me for that later on. So if something goes wrong with you, anyway, I want to caution you. It is extremely dangerous to work with high voltages. You have to know what you're doing. So okay, so far so good. We're going to laminate. I have 2 sheets of there. I have 2 sheets. I've made 2 of them just to make sure if something goes wrong with one, I have another one. So you can see that identical. So I will laminate those. Yep, you have to laminate those. Then you get a nice, and you can see that here on our meter, the last meter. And then the same thing, you get a nice finish, and it's nice and tight, and it looks good. Anyway, guys, to go back, just mentioned my meter. I made that same sheet of voltages on the top. I don't know if you can see it. Yeah, you can see it. So all our voltages are on a sheet on top of the meter. So I didn't bother to get that meter off and get onto that scale and do all sort of things. And to be honest with you, I think I'm going to do that. That will be a hash. So it will look to nothing. So that's why I decided to make a sheet of that and stuck it on top of it. So it's just as easy to if you make measurements. Also there's all measurements. Yeah, resistance measurements is this. The voltage measurements you can use the scale. So anyway, the meter works exactly good. It works right. just you know, with touching the frame, the meter reacted to that. I discovered that when I put the capacitor onto the filament on one side, that disappeared, so that was solved. Okay, so far so good. I'll no chatter. I will use this as an introduction, and the next video will be on building. I will laminate that now and get that all in order. Let's just have to. I think I'll put this on. You see, there's the sheet. That's just where you make your prints off. So, this hopefully strong enough. This is for fun. Is that not very? Yeah, I have my doubts here. It's very thin. Let's see. So now, okay. I didn't notice that earlier on. Okay. Hopefully that will. Ooh, yeah, look. Oh, okay. Perhaps I need some other board for that. Anyway, perhaps with the cabinet should be okay. For cabinet that should be alright. That doesn't have to be strong. But where you put our stuff in our transformer and all that and so on the front of this, you can use this board, and it's a bit thicker. It is also the same thing. You dremel that off and what you need, and then you have a nice sturdy front and a sturdy bottom. I have that still here, so that will be okay. Anyway guys, I'll leave it at that and come back to you when we are starting the build of this signal generator. I'll see you then.